Hi everyone, welcome to School Coaching Point. Today we will discuss few questions from the topic Circle of class 10. Download the PDF from the link given in the description box. Subscribe and press the bell icon for more videos. This is the question number 1. Prove that a tangent to a circle is perpendicular to the radius through the point of contact. So this is a circle. AB is the tangent at the point P and OP is the radius. So we need to prove that OP perpendicular to AB. So let O be the center. Let O be the center and R be the radius of the given circle. O be the center and R be the radius of the given circle. To prove that OP perpendicular to AB. To prove that OP perpendicular to AB. Construction. So we need to construct OQ. That means we need to take a point Q on AB. So take a point Q on AB. So take a point Q other than P. So Q is a point other than P on the tangent AB. So take a point Q other than P on the tangent AB. So Q is a point other than P on the tangent AB. Join OQ. Join OQ. So while it join OQ, it intersects the circle at the point R. So which meets the circle at the point R, which meets the circle at the point R. So proof. So OP and OR, these are the radii of the same circle. So radii of the same circle means what? They should be of the same length. So OP equals to OR, radii of the same circle. OP equals to OR, radii of the same circle. Because since these are radius, so they should be of the same length. OP equals to OR, radii of the same circle. Now OQ equals to what? OR plus RQ. So OQ equals to OR plus RQ. So OQ means it should be equals to OR plus RQ. Implies OQ equals to OR and OP, both are same. So you can replace, instead of OR we can write OP. So OP plus RQ implies OQ greater than OP. So why OQ greater than OP? So for example, 3 equals to 2 plus 1. We can write 3 equals to 2 plus 1. So it means what? 3 should be greater than 2 or 3 should be greater than 1. So exactly same concept we can use. OQ equals to OP plus RQ. It means OQ should be greater than OP. So we get OQ greater than OP. So OQ greater than OP, it means OP less than OQ. OQ greater than OP means OP less than OQ. So thus OP is shorter than any other segment. OP is shorter than any other segment joining O to any point of AB. So thus OP is shorter than any other segment joining O to any point of AB. Therefore OP perpendicular to AB. So this is a concept from class 9. So you have already learned in class 9. So this is a concept from class 9. So in class 9, so we got one concept. So what was the concept? Suppose this is a given line and A is a point outside of the line. So from this point A we can draw infinite numbers of lines. So among all these lines, the shortest distance is the perpendicular distance. So here AD is the shortest distance, so AD should be perpendicular to BC. Exactly same concept, OP is the shorter one. So OP is shorter one, so OP should be the perpendicular distance. It means OP perpendicular to AB. So let's discuss one question related to this theorem. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q. OQ 13 cm is given, OP 5 cm. Find the length of PQ. Solution. So we know that the radius is perpendicular to the tangent, or tangent is perpendicular to the radius. So OP is the radius. OP is the radius and PQ is a tangent. So OP is the radius, PQ is a tangent at point P. So hence from the previous theorem we can write OP perpendicular to PQ. So from the previous theorem, tangent is always perpendicular to the radius, so OP perpendicular to PQ. It means angle OPQ equals to 90 degree. Since OP perpendicular to PQ, so it means what? Angle OPQ equals to 90 degree. So we get OP perpendicular to PQ. So angle OPQ equals to 90 degree. If angle OPQ is equals to 90 degree, so we can use the Pythagoras theorem in triangle OPQ. So using Pythagoras theorem in triangle OPQ. Using Pythagoras theorem in triangle OPQ. So OQ square equals to OP square plus PQ square implies OQ square means 13 square equals to 5 square plus PQ square. 13 square 169 equals to 25 plus PQ square. So 169 transposing 25 to the left hand side. 169 minus 25 equals to PQ square. So 169 minus 25, 144 equals to PQ square. So implies PQ square equals to 144, implies PQ equals to 12 centimeter. Since PQ square equals to 144, so PQ should be 12 centimeter. So using the Pythagoras theorem in triangle OPQ, OQ square equals to OP square plus PQ square. So putting the values, 13 square equals to 5 square plus PQ square. So 169 minus 25 equals to PQ square. 144 equals to PQ square. So implies PQ equals to 12 centimeter. So let's move to the next theorem. Prove that the length of two tangents drawn from an external point to a circle are equal. So in this case, from this point A, AP and AQ are the two tangents drawn from the external point A. So answer, let O be the center, let O be the center and R be the radius of the given circle. Let O be the center and R be the radius of the given circle. AP and AQ are two tangent. AP and AQ are two tangent drawn from the external point A. So AP and AQ are the two tangent drawn from the external point A. To prove that AP equals to AQ, to prove that AP equals to AQ. So AP and AQ are the two tangent drawn from the external point A. Construction. So join PO and OQ. Join PO, OQ and AO. Join PO and OQ. Join PO and OQ. AO also we need to join. So we know that tangent is always, we know that tangent is always perpendicular to the radius. So this theorem we have already discussed. So tangent is always perpendicular to the radius. So therefore OP perpendicular to AP implies angle APO equals to 90 degree. Similarly, OQ perpendicular to AQ. OQ perpendicular to AQ implies angle AQO equals to 90 degree. APO 90, AQO 90 degree. So APO 90 degree, angle APO 90 degree, angle AQO is also 90 degree. So now in triangle AOP, and triangle AQO, in triangle AOP and AQO, hypotenuse in these two triangle AO is common, so hypotenuse AO equals to hypotenuse AO, because AO is the common side for both the triangle. So in these two triangle AO is the common side, so hypotenuse AO equals to hypotenuse AO common. OP equals to OQ. Why OP equals to OQ? Radii of the same circle. OP equals to OQ, radii of the same circle. Therefore, triangle AOP congruent to triangle AQO by RHS, right angle hypotenuse side. So by RHS, both the triangles are congruent, because in RHS their hypotenuse should be same and one of the either side should be same. So therefore AP equals to AQ by CPCT. So if these two triangles are congruent, it means their corresponding side should be equal. So AP equals to AQ. So in triangle APO and AQO both are the congruent by RHS, hence by CPCT AP equal to AQ.